Okay, good evening, everyone. Just to introduce myself briefly, my name is Chris Thorncroft. I am director of the Atmospheric Sciences Research Centre, which is housed in this building. And I'm just going to give you a brief introduction to the centre with just a couple of slides in case you didn't know much about the centre. So our ASRC, first of all, houses and runs the Faulkner Lecture. We have several. We always run it in the spring semester. Our next lecture is in 2 weeks' time. On the Thursday, right? Again that week. We also have, if you're feeling adventurous, we also have a seminar, seminars in the summer as well at Whiteface Mountain. If you're interested in that in the summer. But I just wanted to introduce quickly, and that's Whiteface. That's the silo with probably the tallest building in the States, because it's not that Whiteface is the tallest mountain, but I think it's the only mountain that high with a building. So we do atmospheric chemistry there. So that's our mission. We try and do applied research of relevance to society, be it into the atmosphere, the physical atmosphere, the chemistry atmosphere, as well as the chemistry. But just to briefly highlight, Atmospheric Sciences Research Centre has a lot of people. We have about 100 people, consisting of full-time research faculty and directors. We have 25 researchers and postdocs. We have 25 other staff and technicians, and roughly 32 graduate students, making quite a large group on this campus. Within the centre, we have a number of other centres, including, a dream of a centre for AI-driven forecasting. We also have a Centre of Excellence in Weather and Climate Analytics, Centre for Weather Innovation and Smart Energy and Resilience, the New York State Mesonet, which we're going to hear more about today, and the New York State Weather Risk Communication Centre. We have a number of impressive facilities, including labs, including a calibration lab for the Mesonet, a dream of a radar lab. We have a Sprinter van that does air quality. We have a van that drives around, does air quality. The Whiteface fill station. We are creating a wind tunnel. And we have the Excite lab, which oversees a lot of our artificial intelligence and data visualization. Just to highlight very briefly, these are our core research areas. A lot of interest in renewable energy and grid resiliency, weather and climate generally, be it modeling, forecasting, extremes, cloud and aerosol processes. A big history of developing sensors that actually measure the environment, as well as radar meteorology. An historical interest in boundary layer meteorology, understanding the lowest kilometer of the atmosphere and how the land and the atmosphere interact. Also a growing expertise in urban weather and climate, where most people live. We look at the human impacts, air quality, heat, flooding. Again, we have sensors and modeling we do a lot of work with New York City, for example. Air quality and atmospheric chemistry, both in terms of monitoring, modeling, and sensors. And the bottom left now is, again, applications of AI and machine learning is obviously affecting a lot of what we do. One slide to illustrate something. We don't just have those core talents. We also try and reach across to other campuses, other departments on the campus. So renewable energy and grid resilience is not just about what we do. We're planning to do much more work with policy, with engineers, and other areas that affects the energy vision for the states. Climate, air quality, and health. So we work with the School of Public Health on the applications of our talents in that space. Weather, climate, and emergency management, where we're working with the College of Emergency Preparedness, Homeland Security, and Cybersecurity. Urban weather and climate resiliency, that brings in health again and policy. And the fifth one is aviation and climate. The bottom right figure, Frank Shomi's over there. It does a lot of work on the contrail formation and the need to better understand what forms contrails. And finally, just to celebrate the building that we're in, we've been here just a few years still. So in addition to the Atmospheric Sciences Research Centre, we have the Department of Atmospheric and Environmental Sciences. CHC is the College of Emergency Preparedness, Homeland Security, and Cybersecurity. We have the State Weather Risk Communication Centre, the Mesonet. The National Weather Service is on the 4th floor. Environmental Engineering is here. WISER is the Energy Centre and Centre of Excellence. University, you probably saw it down here, the main building. The main room on the left as you walk in is the university's business development, so that highlights the interaction with the private sector. And last but not least, we have the Excite Laboratory. But anyway, this is just a fantastic building to work in, to not only do atmospheric science, but also how it relates to other areas of talents. So that's enough of ASRC. Now we get to the star of today's show. It gives me great pleasure to introduce tonight's speaker, Dr. June Wang. She's director of the New York State Mesonet and also a research associate professor in the department. Briefly about June's background, she did her bachelor's in atmospheric sciences in Beijing, PhD in Columbia University in New York, and then she worked at the as a research scientist at the Earth Observing Laboratory at the National Center for Atmospheric Research, NCAR, in Boulder. That was between 2002 and 2014. After that, she joined us here at the University of Albany, working for the Mesonet and leading the quality assurance and outreach efforts. And it gives me great pleasure to say that June became the director in 2022. And so never look back. So before I wrap up, I just wanted to highlight June is somebody that's valued in the community and in demand. She's a fellow of the American Meteorological Society. She has served and chaired on a number of high-level committees, including with the World Meteorological Organization. So she's on the international stage. Currently, she does many things. Currently, she's vice chair of the Standing Committee on Measurements, Instrumentation, and Traceability for the World Meteorological Organization, which is also on others, too many to mention. And just finally, on a personal note, I just want to say that June provides excellent leadership for the New York State Mesonet and research. And she, together with her team, are doing a fantastic job that we at UAlbany are tremendously proud of. And so June can take over.
Chris, thank you for the introduction. I wonder whether you guys can hear me online. You guys okay?
Yeah.
I think this doesn't work.
I asked previously about Chris whether they can hear. They said they can hear. I'll ask again.
Okay, all right. Can you guys hear me?
Yeah.
Okay, all right.
Yes.
I just want to make sure. And before I start, I just want to tell you guys, if you are interested in touring this building, Mesonet will provide that, especially our education outreach coordinator, Taylor. She will give a tour of the Science on Sphere. When you come in, you saw the big globe. And then she will take you guys to our Mesonet Operation Center on the 3rd floor. So keep that in mind. That means you have to stay to the end. Yeah, thank you very much for all of you guys coming, especially spending your valuable evening time with us. And so today I have to get this out. Okay. Open my PowerPoint. Okay, I think it should be all good. All right, thank you all for coming, and thank you, Sukanta, for arranging this for the opportunity. And today I'm going to tell you guys a few stories about New York State Mesonet rather than academia lecture, all right? So I'm delivering this lecture, but this is really a team effort. We have quite a few of the Mesonet team members are here, so I really appreciate all their contributions for New York State Mesonet. And so started with the story about New York State Mesonet, then 5 stories from snow to potato. I know you guys scratching your heads say, what does that mean? So what does the peppermint have anything to do with New York State Mesonet, right? You will say, it has something to do with New York State Mesonet, all right? I guess you guys all look at it in your phone weather app, right? Especially given last few days. Tuesday we got 80s, and today we got even Adirondack we got 9 degrees, right? So you all look at your phone for what's the weather going to be. This is a screenshot of the ETACT weather station outside in the parking lot from our website. We show the real-time conditions, not today, yesterday, and then we also show National Weather Service forecast, right? The question is, where does this forecast come from, right? I always quiz the kids. We always host a lot of kids in our operation center, quiz them, normally say, from my phone, from the TV meteorologist. Actually, we have the meteorologist from News Channel 13, Paul here. They said from Paul, right? So, and that's my first question. Where does that come from? I did ask the chat GPT give me a simple version of my complicated diagram. So this is where your weather information come from. It's a numerical weather prediction model. It's a complicated model run on supercomputers with physics, mathematics, and AI, all of those things, right? However, this huge model needs directions. And where does that direction come from? It's the weather observation. Like our GPS, they give you direction. Without this observation, without the data, it doesn't know where to go, all right? So weather observations or weather data come from all kinds of sources. In the space, we have satellite data, and in the air, we have aircraft, we have weather balloons, we have drones, we have all of other things. On the ground, we have weather radars, we have ground-based weather stations. What I'm going to focus on today is one type of the ground-based weather network called Mesonet, right? So what is a Mesonet, right? Mesonet is a combination of two words, mesoscale network. So mesoscale network, mesoscale means spatially weather events from few miles to 100 miles, temporarily from a few minutes to days. So if you look at this diagram, basically thunderstorm, heavy rain, frost, typhoon, all of those belong to mesoscale weather events. So this is what the Mesonet is, all right? We are not alone. In US, we have about 41 Mesonets. 41 states have Mesonets. 37 of them already established. 4 of them, mainly actually in Northeast, are in planning state. I should change the color for Maine Mesonet. They already put 3 sites out. And 11 of them don't have anything. Actually, we are work with Puerto Rico actively on the Puerto Rico Mesonet. And however, I would like to say we are the most advanced one. It's not because I'm the director. It's really true. We are the most advanced one. Hopefully by the end of this talk, I can convince you, right? One of the things we need so many of all of the states have the Mesonet. We know the weather doesn't care the state boundary, doesn't care even the country boundary, it just go by its will. We need all kinds of observations, right? Okay. Let's see. Right. First story. It's about our story, New York State Mesonet story. The idea started in 2011 after Hurricane Irene and Tropical Storm Lee. Actually, it was led by Chris Shawcroft. Is the grandfather or something like that? No, Mesonet. It was started by Chris. And National Weather Service, they found after those 2 storms, there were big holes in Adirondacks in upstate New York. It was flooded, but we did not have enough observation. So National Weather Service was on what's going on. Then, why do we want to set up New York State Mesonet? 3 reasons. First of all, extreme weather events in New York State happen a lot. We have all kinds of weather events in the past and in the future based on the climate model simulations. The studies have found New York State is one of the most economically vulnerable to the weather events. Lastly, if you look at what we had before New York State Mesonet, we only had 27 stations. You see the big holes in Adirondacks and in Catskills and other regions too. And then they don't have enough every variable measure like soil temperature, soil moisture, right? So we started the proposal stage in the summer of 2012. We did not know where to get the money. And then Superstorm Sandy happened in the fall of 2012. So we got supplemental fund for $30 million investment as part of the Superstorm Sandy. We were funded in April of 2014. Our first site went out August 9th of 2015. Right now we have about 25 sites already 10 years old, right? And then last station was installed in February of 2018 in Stony Brook. And then we also established 2 macronet throughway and New York City macronet. And we put another station out, Lake Placid, in 2024. And then we put 3 ConNet stations in New York City last December. So that's the whole story, the history of the Mesonet, where we came from, all right? What does the Mesonet look like? Here is 1-page summary. We were established, it's mainly for early warning weather detection system. That means you need high quality, high spatial coverage, high temporal resolution in real time. All right, so our mission is to provide the best data, best products, best service in real time with the goal of saving lives and properties for New York State. We have a network of 6 networks with total 216 stations. We plan to put 4 more. That will make us 220. It will be something to celebrate after we finish that. And the backbone of the 6 networks is our standard network, those blue dots, 217 stations in New York State. So 17 miles spatial resolution. That means everywhere you stand in New York State within 9 miles, you can find your own backyard weather station or your neighborhood weather station, all right? So all data are reported every 5 minutes in real time. And right now, Nathan can correct me, we have over 12.4 billion observations, depends on how you count it, right? We have 10 years of successful operations. It's not just those data and we provide data. It's the experience, expertise, and the infrastructure we built up during the last 10 years. So that's how we expanded beyond New York State. If you look at today's Albany news, we are managing the main Mesonet data too. All right, so what does that look like? Based on the definition of the Mesonet, you want all stations exactly same. In that way, you can better manage them. You can have good data, all right? This is our South Bristol stations in the Finger Lakes region. It's a vineyard. Those are great trees. It's a 10-meter tower seated in 10-meter by 10-meter fenced areas. All 127 sites are exactly the same. Where do we measure? So we measure all of those standard meteorology variables, pressure, temperature, humidity, winds, precipitation. We also measure additional things like total solar radiation for solar energy, soil moisture, and soil temperature at 3 levels below the ground. We were also the first camera network. You will see some videos, camera images. Every site has a camera. Every 5 minutes, we get a camera image. It has been proved very useful for emergency management and the National Weather Service for situation awareness. And the site is totally self-sustained. You see the huge solar panels, so that provides the power for the whole site. We have 6 batteries here. If you cannot get charged within 2 weeks, I think it's 2 weeks, so we don't really need anything charged. And then in terms of communication, works like your phone. Every site we pay monthly fee to the Verizon or AT&T. Just add those together and it's lots of money for that bill. So it's two-way communication. We can get data in real time. We can also send a commander to the sites to change things around, all right? All right, let me move on to my first story. It's about snow story, right? This past winter, we already got a lot. We might get more, all right? So this is our snow depths map at 8 a.m. on March 4th, about 1 week ago. So like you see Tuck Hill, there's at Adirondacks 2 to 3 feet of the snow. Pretty much the whole state was covered by white snow, right? What does that look like this morning? This is what this looks like. That's the warm weather bringing the whole snow melted, right? And only in a few areas in Adirondacks, still some snow-covered areas. Other areas completely clear, right? Okay. Let's look at one site. This is our famous site. It's the Bigfoot site in Tuck Hill here. Right? He has been living here for 6 years or so. And this is on March 4th. He was the labs were totally buried by snow, right? And what happened this morning? I think he's very happy. His labs are out of the snow, right? Feel much better. So that's the camera image really show you what's going on there, right? So the snow melting, you might be happy, so you don't have snow on your yard. However, snow melting also causes all kinds of flooding and ice jams. So you see those SUNY Schenectady got flooded, and Adirondacks is footprint because of the ice jam. And this is Camden, our site picture. You see the pond that was built up, right? So, all right. That means we really want to make the measurements of the snow, right? How do we measure snow? When I was talking about what we measure actually, I did not mention snow depths. We do measure snow depths every site, every 5 minutes. Thank you guys. Every 5 minutes to the stick. To use this one, this send a acoustic wave to the ground and listening to the signal return. And that times the speed of the sound. Will know the distance from your sensor to the ground. When you get more and more snow, that distance is getting smaller. The differences will be more snow. So that's how we map out the whole state, how much snow on the ground. But we want to know how good this thing is, right? Send our technician when they go to the site in winter, they do snow form. Actually, Johnny is here. Stop. No, Johnny is not here. This is Johnny, and he did the snow core measurements. We also have the snow network and 20 sites. The snow depths is all 127 sites. This cylinder ones measure snow water equipment. You want to know how much water in the snow. That's really important in terms of body. And it's a gamma ray radiation sensor. It's complicated. So we use this Adirondack snow core, not the snow depths, also how much water in the snow. And use that to validate the false instrument, all right? So here's a comparisons between our SR50 this sensor and the manual snow depths. Here's one-on-one line. It's very good agreement. Although systematically, we see our SR50 measurements a little bit underestimate compared with the manual one, right? And just give us confidence on how good this sensor is. And then it's really challenged to make snow measurements. If you go out, you see the snow does not just come down vertically, it comes with winds, right? We have lots of snow drifting. This is a video from our site that show you the snow waves. There's a name called Satsugi, right? You see the wind carry the snow across the whole field and creating the snow waves similar to the ocean waves. And this is one kind of schematic. Our technician Scott went to the site and mapped out the flow depths. As you can see, here's our site, 39-inch 42, and outside you can even get 11-inch. How inhomogeneity the snow depths would be. It's very challenging. So our technicians, when they go out, they are not just one location. They measure the snow depths, sample that in 8 locations. Here's one site in Osceola. Last year, it's 4 feet fence. As you can see, the site was totally buried by snow. And then they make measurements of the snow depths at all those 8 locations. In that way, we can know inside the fence how inhomogeneous, what kind of inhomogeneity we have for snow depths, right? Another thing is, I hope you guys notice, for our camera image, we have a fence. We also have the traditional snow stick, right? On the fence, visible on our camera image. In that way, every 5 minutes, you can see how much snow that is. So, and as you can see here, Code Brook, it's over 2 feet of the snow there. So we asked Taylor to read all of those manual ones to do a comparison. Here's a comparison from a camera and from our manual measurement. Very good agreement, right? But that's really labor intensive. What we really want is develop an AI or machine learning method to automatically grade it, and then Taylor does not need to do that anymore. So, but this is a really useful resources. So when you have places you don't have this, you can use your camera with a snow stick and to get the snow depths every 5 minutes. All right, let me move on to peppermint story. I know you guys are waiting for that, right? It's a peppermint story. Actually, it's a rain gauge story. How do we measure the rain? The rain gauge, I did bring one. It's called wind gauge. It's a very sensitive scale, similar to what you have at home, but much more expensive, $3,500. Very sensitive one. Then you get to have a bucket sitting on top of this, and then you have an outlayer share on the top of that. Right? Every 1 minute you whip this bucket, the differences will be whether there's rain or not, right? And given this sensitive scales and everything, it's perfect, right? However, once you put it out, remember it's not just our weather station. All kinds of creatures, they live there, right? That's their homes too. You should give them a freedom to go wherever they want to go, right? We do see all kinds of creatures. For example, spider rats, they want to build homes around the rain gauge. Snails, they want to hide it under that. So all of those things you might say, why does it matter, right? They either climb it up, get into the bucket. Remember, this is very sensitive. The small weight will count it as rainfall, and that's what we see from the camera. We see clear sky, but our rain gauge say there's a rain, right? So even worse, spider web, it get into our electronics under that and build a gap and make it not evil, not leveled. So in that way, it introduce a huge noise precipitation or rainfall there. So our staff have been brainstorming. I don't know whether it's Taylor, so Nathan, somebody came out with the idea, say, spider webs, they hate peppermint. So that's how we came out peppermint, because we want something environmental friendly. We don't want to just put pesticide to kill them, right? We wanted them to leave them. We just want to say go away a little bit, not under our rain gauge. That's where we put the packets out environmental friendly. We also want to monitor them. Then Nathan created this map. How many stations we put it, how long we put it, how efficient they are scared the spider webs away. We just started this last fall. So far we think it's working. We still need to test it this year. So we have this monitor what's going on. That's our peppermint story, right? It's scientifically sound, I think so. All right, our next story about ring gauge is snow domed ring gauge. So this outshell, this side is heated, all right? When you have snow, it's supposed to melt it. However, when in New York State, we have very heavy wet snow, they can build it up on the top of that. That means when you have heavy snow, it stops measuring precipitation. So if you have some ideas, let us know. That's what we plan to do this year. All right, flooding story. Back to 2019 Halloween flood. And that was a huge flood. Generally, a lot of rainfalls, 2 to 6 inches of the rain, south of the Adirondacks, north of the Mohawk River. 2 of our sites got 5.46 inch within 24 hours, those 2 sites. And the whole storm caused flash floods, record river levels, all of those things. And at least 1 death, and 18 homes were destroyed, 271 homes damaged. The total damage was about $33 million. And you can see that this town, the street was flooded, right? So how can our data help in terms of warning, in terms of inform general public of what's going on? Our former intern, Andrew, did this study. What you see here is time series of the maximum precipitation intensity, blue lights, and the red line is cumulated precipitation for 5 hours. First of all, you see huge, very heavy rainfall around here and then here. And around 8:20 p.m., National Weather Service had a flash flooding warning, right? Later on, around this time, this huge, very heavy rainfall, they changed that to flash flood emergency. There was also a report regarding the street was flooded, all right? And this is a quote from National Weather Service. New York State Mesonet observation have been key to assessing near-term flood potential and wind threats with the storm. That's how we provide real-time data to inform them. Remember the forecasting coming from numerical weather prediction model. However, the meteorologists like Paul, like National Weather Service in the 4th floor, they look at the real-time situations, they look at the forecasting to see how the forecasting is performing. They can change from watch to warning or something else. That's how our data are also in real time assimilated to the numerical weather prediction model. All right, this is our flood story. Let me move on to teacher story. This is a story from Crystal Colonel from Arcadia Middle School in Clifton Park. She worked with us for a couple of years in summer to develop curriculums using Mesonet data in the classroom. So for earth science or meteorology class in middle school, high school, you need to teach kids about what is the cold front, right? You use this schematic diagram, say, here's cold front, you have a cold temperature behind that, a warm temperature in the front, and you can join the line on the map to tell the students where the cold front is, right? This is a very conceptual, right? It's kind of boring too, right? So what if we use Mesonet data? Actually, this is 2022 Christmas Buffalo blizzard. This is apparent temperature. In other words, it's feel-like temperature, all right? Look at the Western New York, minus 28 degrees. Look at the East, 43 degrees, right? You can spot the cold front, right? You can, right? I also put the wind bar, and behind that, how windy that. Here's your cold front, right? So that makes the whole thing very interesting, and the kids can learn. They can even use the data mix, visualize the plots, and learn Python on data visualization, data analysis. We are not stopping there. What does that mean, cold front behind, besides cold temperature versus warm temperature, right? Let's look at the camera images. Look at the Western New York Delaware. It's snowing, the poor visibility, and right, very bad weather. This is the site from here. You look at the Whitehall, 43 degrees, blue sky, right? That's kind of the whole situation, awareness, visualize, and to let kids know what's going on. What is the cold front? That's our teacher's story. What's my next story? It's the potato story. That's his favorite story. He always tells people about potato stories. Actually, it's an agriculture story. We asked our site host from Gabriel, it's a potato farm, to write the story for our quarterly newsletter. And he wrote this. There were 3 parts. First of all, he used wind speed to help him spray the crops. If it's too windy, right, you don't want to spray. It will go with the winds. It won't fall on your crops, right? That's first thing. The second thing is he used the soil temperature for spring planting, for fall harvesting. Why harvesting? If the soil temperature is frozen, you don't want to harvest your potato. You will break the potato, right? He even wrote, the potato will be the happiest when you harvest at the right time. That's the second story. The third one is they use the data to help the workers in the field escape from the field to shelter before the rain starts. And then the last story is about his $1 million view. He labeled, this is his site camera image, he labeled all of those peaks, because it's in Adirondacks, peaks from his camera. So it's not just the emergency manager, it's just the general public and our site host, all of those stories, right? Okay. Here's what Gabriel's that site potato farm looked like yesterday. After the snow melt, it's totally flooded with all the snow, right? All right. I have way more stories to tell. I know we have limited time. Our data are used in all kinds of sectors, state governments, all agencies, whoever needs weather data, federal government, and also commercial. One of the common pretty much every day, Taylor has to provide the data to forensic meteorology, sleep and fall. If you were here last week, that was the Faulkner's lecture about it. and renewable energy, road safety, and aviation. Oh, I already mentioned agriculture, all kinds of the things, all right? So, I have a homework for you guys. Use your phone to scan this QR code. You can get into all kinds of Mesonet website. Our main Mesonet website looks like this. If you click that things, it will take you to the place where you put your zip code. You will find your own backyard weather station or your neighboring station. But some people don't really have a backyard. Right? So find your backyard weather station and bookmark that. Next time you can tell us your stories. All right. Also follow us on social media, and Taylor is our social media manager too. We want people to follow us. We have great stories and videos too, like what do our technician do in the field. All right. All right, I will leave you guys with this video from Central Scare more than a year ago, the snowstorm. I think I'm going to stop here.
There we go.
Yeah.
Thank you, June. It's actually feel colder. Okay, thank you. Okay, the floor is open for questions. Anyone?
Questions, comments?
This is all land-based,
Yes.
right?
Mm-hmm.
Who does forecasting for planes? For flying in altitude?
Yeah, that's what we do too.
We do that.
I because of the time limit, I did not really show you one thing. So remember, I told you guys we have 6 networks. I only show you one standard network. So I have a nice slide to show you that. So one of the things that we know, weather happens in the air, right? Not on the ground. So we do have so-called profile network, and with a macro radiometer and the wind lidar, two expensive instruments. Basically what they do is measure continuously temperature, humidity, and the wind in the air. And then that ingested to the forecasting. And then your question is specific for aviation, right? Let's use our wind lidar as example. It does give you the turbulence measurements too. That's very important for aircraft, for airport. We do have one of these stations in Albany Airport. And then we also have flux network that's basically measure energy exchange between the atmosphere and the ground. And we also have the snow network I already mentioned. Those sub-network is the reason, are the reasons why we are the most sophisticated one. We are the most advanced one. We are the only one among the 41 with those networks.
Yeah. How high up does that wind meter, how high up does it measure the turbulence, like way up?
The wind lidar?
Yeah.
The wind lidar goes wherever the cloud is, and so it's blocked by clouds. But if it's a clear sky, it can go as high as 7 kilometers. And so I did not mention, you can see we have not just the winds, we also detect the wildfire smokes, aerosols in the air. And you like smoke aloft, here's clouds and a fog and good smoke. So other information too.
Yeah.
I might have missed this, but how do you, with the profiler, measure the temperature way up in the atmosphere?
Yeah, very good question. This mailbox sense, so-called radiometer, is a passive remote sensing. So it does not, like lidar is an active one. That means it sends out a laser. It's an ISIC, right? It's an ISIC laser to the air, and it detects the particles in the air, detects the movement of the particle. The passive one, macro radiometer, is 32 channels. sitting there to measure the microwave radiation at those 32 channels. Then 32 channels are sensitive to different things. Like oxygen, we can get to the temperature profile. Water vapor, we can get back to the water vapor profiles. Different channels are sensitive to different altitude. That's how we get the profile. Make sense?
I
Okay,
think so, yes.
Paul.
First of all, congratulations on the on running the Mesonet. We appreciate that, and all the years now that it's been active. Is there anything on the horizon on the Mesonet that isn't currently in the kit, so to speak, that we see at all? And one thing in particular that I happen to be interested in, and you talk about the public using this. I tend to use a lot of cameras to show my viewers what the weather is like in certain areas. And I think the public really responds to being able to visualize it. And as scientists, we're fixed a lot on data, on the numbers and the charts and everything. I think the general public really responds to more of a visual. And one of the things that I had hoped to see from the Mesonet over time, perhaps, was more of the visual from the camera, if you can move the camera. So oftentimes I see that there's storms in an area, but the camera's not facing the right way to see those storms. Is there anything on the horizon that, or maybe not just the camera, but other things also that you see coming down the line?
Let me first comment on the camera ones. I know we want the 362. All right, our VPR did ask us to put one tested in the ETAC too. One of the things limited us is the bandwidth because we are on Verizon, we are on AT&T. But definitely something we can think about it. Actually, somebody just sent me an email yesterday from UK. His company has this. So I think maybe something to collaborate with you guys. I know your van has some 360. At least for our profile network, we are on the Wi-Fi on land communication, not the Verizon. We might be able to do that. Another thing is, go ahead.
It'd be nice to have I would dream. This is not serious, but it'd be nice to have the 3D camera with those virtual things. So you just do that. Look around. It wouldn't work on television, I don't think.
Another thing is the camera is not situation awareness. It's great. We also SRC also use the camera image, apply AI method to pull out visibilities, precipitation type, even flooding, water levels. Those are the things we are working on too. And then what's on the horizon? One of the things is air quality. Scott Miller from SRC, his group developed this low-cost air quality package. We already deployed them at 38 stations in New York City and surrounding regions. We are advocating to push for the whole state. And then we have other things going on, besides our profile network, drones, and ground-based GPS, it's more of my own. You can get 3D water vapor. And there are other new technologies so we are exploring, like reusable radio sounds and basically glided sound, those new technology.
Great. Thank you.
Yeah, I have a question because I've been in the New York State a few years. And from my observation, looks like predicting the slow storms into the electron. Every time when they assess, there will be a slow storm there is. But during summertime, because I also found when it says it's going to rain at 2 o'clock, actually it didn't come at 2 o'clock, and then it says 4 or 6. So is it true the reliability of prediction the storms is much more is higher than predicted rain, and why?
Okay, that's a really good question. You are a very good observer in terms of what's going on in terms of weather-wise. Snowstorm, it all depends on what kind of snowstorm. let's say for New York State, lake effect snowstorm, snow types, it's very common along the Lake Ontario, Lake Erie. It's a little bit bigger scale. It's a little bit easier to predict. However, those thunderstorms, summer thunderstorm, we call deep convective events, that's very localized. It's very hard to predict. We often get emails from public, send it to our Mesonet email saying something wrong with your rain gauge because, I saw rain here, but my site did not record anything. That's the localized one. Even with our 127 sites, still not enough. That's how the AI can help. How to downscale, actually, Contest Group is working on that. With 127 stations, you can downscale to 3-meter resolutions for wind gusts, other things. Localized is hard.
Also depends what channel you watch, right, Paul?
Yeah. So Kitty, I get back.
It's only one chat.
Yeah, only one check, yeah. Anything online?
There is one question online.
Okay.
And you go here, Kristen.
International forecast. So last time I checked, possibly mounting different signal down there. Okay. All right. I think I already mentioned a little bit how our data are integrated into the forecasting. First of all, our data are sent to National Weather Service in real time and assimilated into the numerical weather prediction model, all of the surface data and the profile data. And that's one way. And then our data are in real time sent to weather forecasting office, like the 4th floor. They have display in their operation center with our data, with our camera image. That's how they can see what's going on in the real time. I don't think forecasting, we don't do forecast, we are the real time monitoring. So forecaster won't show is at this side, what is the temperature? So
The surface observations are assimilated.
yeah,
The profilers are not assimilated.
yeah. Yeah, the question is more of why our stations are not show up on the
We have a
forecast.
helium story. Let's see the helium story.
Or you can tell.
So there's a helium story a few years ago, and still now, I guess there's a shortage of helium. And the backbone of any numerical weather prediction system are balloon launches. And they take place in New York State at 3 sites, including Albany, and they're launched twice a day. And they are the most valuable data you can get for assimilating into models. And you really want to keep them going. But a couple of summers ago, there was a severe helium shortage. So they had to reduce the number of balloons that were being launched. So this is a positive story for the Mesonet because the profiler sites that June just talked about, we have 17 of those sites, and they are making profiles vertically every 5 minutes. So that's valuable data that forecasters were actually using in real time. In no means do we say they replace the balloons because there's still kind of estimates for those profiles, but in the absence of profiles, they provide valuable data. So there was kind of a nice story for the Mesonet to step in the time when there's less balloons being launched.
I want to ask anybody from India Letters Farm? No, it's one of our site. I just want to. That's okay. All right. Any more questions? No.
But this building has a supercomputer for Mesonet data processing.
Yeah, we do have. How many servers do we have?
Like 6 servers, but they're separated into VMs, so around 30 VMs roughly.
Yeah. So we do have we archive everything, not just the 5-minute data, 3-second data. Our raw data is 3 seconds, and all camera image are archived. And our university does have a really good supercomputer. So yeah. All right. If not, yeah.
So you mentioned there are a lot of Mesonet. So could you kind of illustrate what's the unique feature of our Mesonet compared with others?
Yeah, we have the best one, aren't we? Okay, the subnetworks, we are the only one with those. And now we have two macronet, the Thruway and New York City macronet. The New York City urban network was the most dense urban network in US. And then every Mesonet was created to start with focus on specific things. Like we are on early warning, and the main Mesonet is part of agriculture extension. So they are focusing on agriculture. North Carolina is on agriculture. There are others are more for hydrological drought. And so different focus. In terms of uniqueness, I would say there are two types of the Mesonets among those 41. One is more high level, like Oklahoma Mesonet, New York State Mesonet, every site exactly same. And we did not adopt those different networks and put them together. Then the second type is put all of those different networks together. They do some processing of the data, right? I think that's kind of two types of the thing. 3D Mesonet side, some Mesonets start to launch drones. We are thinking about that. It's not manually, it's automatically go out and come back and then go out again.
But we are the only 3D Mesonet.
Yeah.
And cameras, we're the only one with cameras, right?
Right now, everybody follow us.
Oh, okay. Okay, we need the 360 degree.
Okay. Not any more.
I think so. Do you want to say something about the tour again?
Yeah, I do have some, stickers, magnets, and brochure. But Taylor, you will take. Who wants to go to the tour with Taylor? Okay, Taylor will.
Together out there.
Yeah, you guys follow Taylor.
Can I like to thank June once more time, so give us a round of applause.